Cool. Okay, for those of you who are now on Twitch, hi guys, welcome. Just waiting for the YouTube data to start sending, and then I will make a stand, or make a start, and there we go. We are good for YouTube. Hi guys, welcome to this, another live stream for the NAPLAN papers. This one I'm going to do 2012. I am not affiliated with NAPLAN or Akara. My name is Darren from MaffsGuru. Thank you very much for watching. If you can, go over to MaffsGuru.com. I'll even write it on him, MaffsGuru.com. Sign up, totally free, loads of stuff on there, year 9 content, 10, 11, 12, the works, with downloadable notes and all sorts of stuff to do. So again, I am not affiliated. These are just my solutions for my students who might be out there and watching. Hopefully they are useful. Fingers crossed I can get this done in about half an hour to 40 minutes. Again, if you are watching out there and you notice that I'm about to do something really stupid, let me know, and then I will try and correct it as we go along. But otherwise, here we go. Right. Well, about 30 questions to get through. The picture shows 5 stacks of $2 coins. How much money is there in total? 5 stacks of $2 coins. Well, I think they just wanted to count that, don't we? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lots of $2 coins. I'm going to go for 20 bucks. Nice, easy question to start with. Helen pays $1.19 for 7 prints at the camera shop. How much does she pay for each print? So we're trying to do 119 divided by 7. Well, 7's into 1 don't go. 7's into 11 goes once. Remainder 7, 8, 9, 10, 11. That's 4. 7's into 49 go. Put my decimal point back in there. My decimal point goes in there. So again, I would say $0.17 or 17 cents. I thank you. Luke walks to school every single day. Sorry, Luke, I had to do that. Not a lot of fun, really, is it? The distance from his home to school is 1.5 kilometers. Luke leaves home and walks 500 meters towards school. What fraction of the distance to the school has he done? We've got 500 meters. 1.5 kilometers is 1,500 meters. Let's do some cancelling. The zeros go, 5's into there go once, 5's into go 3 times, and so he's done 1/3. And there's lots of different ways for doing these type of questions. Don't worry about it if you have come up with different ways. It is not a problem. Sharon bought 3 fruit buns and 4 bread rolls at the bakery. A bun cost 80 cents. The roll cost 40 cents. How much does Sharon pay? I don't know, but I'm really hungry now, Sharon. Can I have one of those fruit buns? All right, so 3 fruit buns. So 3 times 80 cents, which is going to be 8, 16, 24. So $2.40 for that. She got 4 bread rolls at 40 cents. So 4, 8, 12, 16. That's $1.60. Add those together is going to give me a total of, I'm hoping, $4. There we go, $4. And I'm still pretty hungry. Joan is making a pattern with sticks. She continues adding sticks as shown. Right, how many sticks will Joan need to make step 6 of her pattern? Right, well, she's gone 6, and then 11, and then 16. So that's steps 1, 2, 3. We want 4, 5. We want step 6. How is she getting there? She's adding on 1, 2, 3, 4. 1, 2, 3, 4, 5 sticks every single time. So it's going to be 21, 26, and 31. All right, so again, just looking for a pattern there. I'm going to say she's going to need 31 sticks to get to step 6. Which of these designs looks identical after a quarter of a turn? Which of these designs is going to look? Well, it's definitely not going to be that one, because if I turn it by a quarter, that thing is going to probably look something like that. Likewise, that's not going to be identical, because I think if I turn that by a quarter of a turn, I'm not even sure what that's going to look like. Or that one. All right, so I'm going to plunk with that one there, because I think I'm fairly sure that's going to look the same after 1/4 of a turn. Shame I can't actually turn these. Which expression is equal to 5b with a floaty 3? Well, b with a floaty 3 is the same as b times b times b in expanded form. So 5b with a floaty 3 would be 5 times b times b times b. So that one would be, well, that one there. 5 times b times b times b. Yep, thank you very much. Job done. Question number 8. The graph shows the price per ton of crops grown in a country. Oof. For several quarters, the price of barley was greater than the price of wheat. In those quarters, the price of canola fell below 500 per ton. Which quarter was this? Sheesh. All right, so let's have a look. I'm actually going to do a different color. So my barley is the one with the triangles on. So let's see, there we go. So there's my barley. All right, so that just makes my life a bit easier to have a look there. Let's do green for, what was the other one? Price of barley was greater than the price of wheat. Wheat is the one with crosses. Okay, so it says for several quarters, the price of barley was greater than the price of wheat. So the triangles are higher than, or the red line is higher than the green line. Okay, so for several quarters, the price of barley, let's change my highlighter. For several quarters, the price of barley was higher than the price of wheat. So the triangles are higher. So let's do those ones there. So that's 1 quarter there, that's 1 quarter there, and that's a quarter there. All right, so they seem to be the ones that are higher. Yep. And it says, in which one of those quarters was the price of canola below 500 per ton? It would seem to be that one there. So 2007, quarter 2. Again, not overly sure what that is to do with maths other than reading graphs. He says, with a lot of maths teachers going, what are you talking about? Well, there we go. Rita is drawing the net of this box. Where should Rita put this symbol star on the net? All right, well, it's going to go on the top of the shape. And so it's trying to work out, do we know what the top of the shape of this is going to be? Well, basically, this bit here is going to be the top. And that's very much where they want the star to be placed. So I'm going to say that it would have to be here. So that's a 3D visualization spatial thing. Dean uses the same rule to change each triangle into a square. Which of these rules did Dean use? 2 to 4, 3 to 7, 7 to 19. Whew, well, let's see. Let's just do it by trial and error, shall we? Triangle times 1 plus 2. So times by 1 plus 2 basically just means add 2. So did I add 2 to that one? Yes. Did I add 2 to that one? No, I did not. So that cannot be one of my rules. Times by 2 and add 5 to go from, oh, sorry. A square, yeah. Triangle times by 2, add 5. No. 2 times 2 is 4. Add 5 is going to give me 9. It's definitely not that one. That doesn't make any sense whatsoever. Times by 3 minus 2. Oh, okay then. 2 times 3 is 6, minus 2 is 4. That works. 3 times 3 is 9, minus 2 is 7. 7 times 3, 7, 14, 21, minus 2 is 19. There we go. I don't need to go any further. I'm going to use that one, but let's just check. Triangle times 4 minus 5. Okay, so 2 times 4 is 8. Minus 5 is definitely not 4. It can't be that one. So there we go. Question 10. Very, 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 very happy. Terry bought 7 boxes of pencils. In total, this was 84 pencils. Which equation shows n as the average number of pencils in each box? Well, the average number is given by the total number divided by how many boxes. So I do 84 divided by 7 is going to give me n. Now, obviously here they're trying to trick me because they're trying to see, well, okay, so if I do n times by 7, if I move the divide by 7 up, then the 84 gets left on its own. That becomes n times 7. I've got one of those. N times 7 equals 84. I'm going to go with that number there. A standard sized dice is rolled. A standard 6-sided dice is rolled. Okay, there's my die. Which of the following events has a probability less than 1? Rolling a number that is greater than 0. Well, basically that's going to give me a probability of 1 because all numbers are greater than 0. Rolling a number less than or equal to 7. That's going to give me a probability of 1. So that's not my correct answer. Rolling a number greater than or equal to 1. Yep, rolling a number greater than or equal to 6. Greater than or equal to 6. Which of the following events has a probability less than 1? Rolling a number greater than or equal to 1. Yes, rolling a number greater than or equal to 6. Well, you can't roll a number greater than or equal to 6, so that's a bit of a trick. It's going to have to be that one there. Notice even I look at some of these questions and go, what? What is going on here? All right, here we go. Joe filled this empty bucket with water from a tap. First, the water ran from the tap slowly, then the water ran quickly until the bucket was nearly full. As the water reached the top of the bucket, he turned the tap off. Which graph best shows the depth of the water? Right, well, this one here is if the bucket was evenly filled. It isn't. This one here is the tap was turned on really fast and then started to go slower. It wasn't that one. I have no idea what that graph's trying to show you, because basically it was filled up really quickly and then emptied really quickly as well. That's not what the question said, and so it would have to be this one here. All right, so the water was slowly turned on, got faster, and then slowly turned off as the tap was turned off. I think that's correct. I'll just check. Water reached, then the water ran quickly. First the water ran from the tap slowly, then the water ran quickly until the bucket was nearly full. So reach the door, you turn the tap off. Actually, I'm going to rethink that question. I don't think that's actually right. I think this is right. Now, if I think about it, because here, in this one here, they're actually saying it starts slowly, he turns the tap on faster, and then turns the tap down slowly, whereas here it's fast, and then he slows it down, and then it's full. So we're going to go with that one there. Whew, nearly tricked me. To make a syrup, 3 cups of water must be used for every 4 cups of sugar. These examiners love talking about sugar. How many cups of water are needed for 6 cups of sugar? So let's see, we've got 3 cups of water for 4 cups of sugar. All right, how many cups of water are needed for 6 cups of sugar? What am I doing here? Try that one again. Sugar, 4. How many cups of water are needed for 6 cups of sugar? All right, so I've got 2 cups of sugar. Is going to give me 1.5 cups of water, and I want 6 cups of sugar, so times that by 3, times that one by 3 gives me 4.5. I'm going to go for 4.5 cups. Sam leaves home at 10:35 a.m. to go to a movie. The movie starts at 12:20 p.m. How much time does Sam have before the movie starts? So 10:35 to 11 is 25 minutes. 11 till 12 is 1 hour. Sorry, it's 11:12 plus the extra 20 minutes to get from 12 to 12:20. So I've got 1 hour and 45 minutes. All right, so 1 hour and 45 minutes. So 25, 35, 45, yeah, 1 hour and 45 minutes. Which one of these is equal to 3 and 5/7? So they're asking here, can you turn something top heavy or improper? And when I was at school, we had 3 and 5/7. We were always taught to say, well, we got 3 whole ones, that when they were split into 7 pieces each would give me 3 times 7, so 7, 14, 21, plus the 5 additional points at the top would give me 26 on 7. So what am I looking at? There we go, 26 on 7. Question 16. All right, question 17. Which of these multiplications gives the greatest value? Well, let's just do it by trial and error, shall we? That multiplied by 100, I'm going to move my decimal point 2 places. It's going to give me 3.1. Multiply this by 10 is going to be 1.32. Oh, dear me. Multiply... how do we do this one? Multiply that by 0.1. So I'm going to multiply that by 0.1. Is effectively dividing by 10. So that's going to give me 0.0312. And times that by 1,000. 1, 2, 3 is going to give me 0.3. I'm just going to check that 0.312 times 10. Weirdly, I'm going to fire up my calculator because I'm not convinced myself here at this moment in time. But we'll see. Because if I times by 0.1, I'm actually dividing by 10, which gives me 0.0312. But my brain is fritzing with me at this moment in time. So I just want to check. And you're probably sitting there going, well, if you're allowed to use a calculator, now I'm just using it to check. 0.312 multiplied by 0.1 gives me, 0.0312. Yep, so that's the same. So which one of these values is bigger? It would have to give me this one here. Yep, 3.1. 35 times what is a quarter? What our action is equal to? Well, if I have 35 times something equals 14, I'm going to divide both sides by 35. That gives me 14 on 35. What goes into 14 and 35? 7. Okay, so 7's going to 14 twice. 7's going to 35. 7, 14, 21, 28, 35, 5 times. So I'd be looking for 2/5. There we go. That's the first one again. Bindi makes 36 muffins. Some of the muffins were apple and some were pear. Both kinds of muffins looked the same. Tegan took a muffin. She had 1 in 9 chance of taking a pear muffin. How many apple muffins did Bindi make? Right, well, okay then. She had a 1 in 9 chance of taking a pear muffin. Well, 9, 18, 27, 36. 9s go into 36 4 times. All right, so that means she must have made 4 pear muffins. Because if she's done 4 out of 36, that still has a ratio of 1 in 9. So if she made 4 pear muffins and 36 muffins in total, she must have made 32 apple muffins. Whew. Which of these shapes has diagonals that cross at right angles? Okay. Which of these have diagonals that cross at right angles? Again, a bit of a trick question. If I was to draw diagonals there, that certainly is not a right angle. Likewise here. Where are my diagonals here? That's really hard to tell. But I know that my diagonals here absolutely cross at right angles. All right, which one of these shapes has diagonals that cross right angles? I'm going to go for my kite. Okay, and there we go. 21, almost getting towards the end of this. What have we got here? How many edges does this prism have? How many edges does the prism have? Right, well, let's count this. 1, 2, 3, 4, 5, 6, 7. So there are 7 on the top. There must be 7 on the bottom. We are now looking for the vertical edges. We've got 1, 2, 3, 4, 5, 6, 7, plus another 7. 7, 14, 21. I'm going to go for 21 edges. I'm just going to check that again. 1, 2, 3, 4, 5, 6, 7 on the top. Yep, 7 on the bottom. And then we've got 1, 2, 3, 4, 5, 6, and 7. So everywhere there is a point, there is an edge as well. So 7, 14, 21, 21 edges. The table shows the cost of planting a crop in paddocks of different areas. Complete the rule so that it agrees with the table of values. Cost of planting equals what times area of paddock? Well, again, if I've got 1600 and I want to divide that by 20, 2 is going to there once, 2 goes into there 80 times, so it would be 80 times the area of the paddock. But let's just check. If I did 40 times by 80, what do I get? 4 times 8, 8, 16, 24, 32, plus the 2 zeros give me 320, and I've just done the check. So what I did there was I used the first 2 values and divided them, because the cost of planting a crop divided by the area of the paddock will give me this value here. And then what I did was just made sure I could then multiply it. And again, it probably would have been easier to choose 8,000 divided by 100. But anyway, both of those give the right answer. What do we got here? A positive number n is multiplied by 4 and then 20 added. So we've got n is multiplied by 4 and then 20 is added. Which of the following operations would give the same result? Adding 20 to n and then multiplying by 4? No. Adding 4 to n and then multiplying by 20? No. Adding 4 to n and then multiplying by 5. Oh, hold on a moment. It's a bit of a trick. This is a factorizing question, he said. Sorry about that. Let's go again. I've got 4n plus 20. I can take 4 out as a factor to give me n plus 5. And there we go. That's a bit of my trick there. So adding 5 to n and then multiplying by 4. Adding 5 to n and multiplying by 4 will actually give me this one there. Now, I don't know that we do factorizing in year 9, so it may well actually be called a different thing here. I don't know. We can work that one out. I mean, again, I could write 4n plus 20 as 4n plus 4 times 5. And again, if I was to write that out in a table, I'd have 4 here, and I'd have an n here, and a plus 5 there. And that would very much give me the same answer. So that's certainly another way around of thinking it. In a school library, there are 1,000 books, 450 books of fiction, the rest are non-fiction. What is the ratio of fiction to non-fiction? Right, so fiction to non-fiction. We know that 450 of the books are fiction. A lot of people get tricked here by writing 1,000. That was the total number of books. So we would have to do 1,000 minus 450, which would give me 550. Divide both sides by 10, gives me 45 to 55. But divide both of those sides by 5. That's going to be 11, 5, 10, 15, 20, 25, 30, 35, 40, 45 gives me 9. And so we would want 9 to 11. And again, the order for ratios is really, really important. Dale is a beekeeper. Ooh, pesky bees, they hate me. The mass of, Dale is a beekeeper. The mass of 500 millimeters or milliliters of Dale's honey is 700 grams. Whew. So 500 milliliters is equal to 700 grams. How many liters is 3.5 kilograms of Dale's honey? Whew. So 700 grams. So we got 500 milliliters is equal to 0.7 kilograms. How many 0.7s go into 3.5? Well, if I do 35 divided by 7, that's the same calculation. 7, 14, 21, 28, 30, that's 5. So I can times by 5 to give me 3.5 kilograms. If I times by 5 on one side, I've got to do the same to the other one. That's going to give me 2,500 milliliters. And we know that there are 1,000 liters. 1,000 milliliters in the liters. So I'm going to write 2.5 there. See how the questions are getting a little bit harder now, starting to mix the maths together. This table shows Jack's results for a 2-day canoe race. What is Jack's total time for the 2-day race? Again, this is an interesting one. 7:50, 7:54. We got 8:59, 56. Okay, so 54 seconds and 56 seconds. When I add those together, it gives me 1 minute and 50 seconds. So that's 1 minute and 50 seconds. I've got 57 minutes and 59 minutes. Good afternoon, Jai. How are we? Hope all is good. I'm just sitting here at the moment working through a NAPLAN paper, getting to the pointy end of this stuff. So I've just added together those. Let's see, 57 minutes and 59 minutes gives me 1 hour. So what was that? 1 minute and 50 seconds. So I've got 1 hour, and how many minutes is that going to be? 56 minutes. And I've got 7 hours and 6 hours. 7:40, that's going to be 15 hours. So let's add all those together again. So I've got 50 seconds. I've got 56 minutes and 1 minute, which gives me 57 minutes. And I've got 1 hour and 15 hours, which will give me 16. So I'm looking for, what was the Jack's total time for the 2-day race? That's slightly awkward. 6, that's 12, you idiot. All right, so let's try that one again. That's going to be 12 plus 1, which is going to be 13. 13, 56.50. Let's try that one again. Wow, that's a bit awkward. Right, I'm going to go back and try that one again. See if you can get there first. All right, 7:57.54 and 6:59.56. So 54 seconds and 56 seconds gives me 1 minute and 50 seconds. So 1 minute and 50 seconds. All right. 57 minutes and 59 minutes gives me, first things first, that's a 6. All right, so let's try that one. 59 and 57 minutes is going to give me 1 hour and 56 minutes. And I got 6 and 7, let's try it's 13. All right, so let's add that together. I got 50 seconds, 57 minutes, 14 hours, 14, 57, 50. There we go. I don't know what I did beforehand, but life is good. Thank you very much. Job is done. Sarah bought 2 full bags of sand. Both bags had the same amount of sand in them. She used a quarter of 1 bag of sand. She had a total of 35. She's used a quarter of 1 bag of sand. She had a total of 35 kilograms of sand left. How many kilograms of sand were in 1 full bag? All right. She used a quarter of 1 bag of sand and she had 35 kilograms of sand left. So 1/4 of a bag of sand plus a whole bag of sand gave me 35 kilograms. All right, so we've got a quarter of 1 bag plus a whole bag gives me 35 kilograms left. Okie dokie. So let's add those together. That gives me 5 on 4x, gives me 35. Divide both sides, I'm going to divide both sides by 5. 5, 10, 15, 20, 25, 30, 35, that gives me 7. So x on 4 gives me 7. So times by 7, 14, 21, 7, 14, 21, and 28. 7, 14, 21, 28. So in which case, 1 bag has 28 kilos. Let's just check that. So if I did 28 plus 28, that's going to give me 56. Both bags, she's used 1/4 of a bag of sand. So a quarter of 28. How many kilograms? Again, right. It teaches me now for doing silly things here, because that's actually 3/4. So again, if you were watching this a moment ago, and again, that's why I did the check, which is a good idea. If you check, then ultimately you're not going to make a silly mistake. So that's going to give me 3x. I'm going to turn that to 4x on 4. That gives me 7x on 4. Gives me 35. 4, 5, 6, 7. Yep. So 7s into 35 go 5. So that gives me x on 4 equals 5. So x gives me 20. So there's actually 20 kilos. That's going to make much more sense. So if I had 2 bags, I'd have 40 kilos. 1/4 of 1 bag would give me 5 kilos. So then if I take away 5 from that, leaves me the 35. And thank you very much, I've got the right answer. Well, that would have been awkward. Write the answer to this division in the following box. So we got 12.24 divided by 0.12. Well, I know that 0.12, I know that if I, so let's do this as 12.24 divided by 0.12. I'm going to times the top and the bottom by 100. So if I times the top by 100 and the bottom 100, that's going to keep it even. And I'm going to end up with 1224 divided by 12. Yep, and so I can now divide that by 12. Well, 12's going to here once. 12 goes into there twice. So again, we can do this another way. 12 to 4 divided by 12. 12's going to there once. Remainder 0. 12's don't go into there. So carry the 2. 12's going to there. 12. So it's 102 times. And again, there's lots of other ways of being able to do this, but hopefully I've chosen the right one. God, I hope these are the last 2 questions, because if it is, I've smashed through this in a staggering 26 minutes or nearly 30 minutes. This diagram shows a common tiling pattern that uses squares and octagons. The dotted line shows the area of each octagon is a multiple of the area of each square. Oh, cool. The area of each octagon is 175 centimeters squared. What is the area of each square? All right, so let's try that one again. The diagram below, the diagram shows a common tiling pattern that uses squares and octagons. Oh, okay. I'm like, where the flipping heck's the octagon? Here's my octagon. So that's going to help first knowing what it is. All right, so what do we want? The dotted line shows the area of each octagon is a multiple of the area of each square. The area of each octagon is 175 centimeters. The area of each octagon. So what is the side length of each square? Right, so we've got 1. So there's 1, 2, 3, 4, 5. And when we add these together, 6 squares in total, right? So we have 175 centimeters squared divided by 6. I'll just check that. 1, 2, 3, 4, 5, 6 squares. 6 into those goes 6, 12 goes 2. Remainder, no, 6, 12, remainder 5. 6 is into 55. Don't go. Let's rethink this. Okay. The diagram shows a common tiling method uses squares and octagons. The dotted line shows the area of each octagon is a multiple of the area of each square. The area of each octagon is 175 centimeters squared. What is the side length of each square? Okay, so 1, 2, 3, 4, 5. 7. Wow, come on. Now, for those of you out there watching this, it's actually pretty late here. I'm trying to get these done. So there's 1 square, there's 2, there's 3, there's 4, there's 5. This one here would make 6, and that one there would make 7. So let's try that again. Come on, rub that out. Let's make that 7. Let's get rid of that 5 on the top. All right, 7's into 17 goes 7, 14. So 2, 15, 16, 7, remained at 5. 70 to 35 go 5. So the area of one square, the area of one of these squares is 25 centimeters. It's square, so what number multiplied by itself gives me 25? It's got to be 5. So the area of my side. Now again, how did I know I was going wrong in the previous one? Because I wasn't getting a square number. All right, bearing in mind this is a non-calculator question, they'd have to be nice and give me an area that's a square number. Jerry made this paper fan. He uses 10 identical isosceles triangles. Okay, so we've got isosceles triangles here. He uses 10 isosceles. When the fan is open, it forms a straight line. How many degrees is the angle marked A? Okay, Right, we can do this. So we've got how many? We know that the whole thing here is 180 degrees. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I do 180 divided by 10, that's going to give me 18 degrees. Now the reason I've done that is because I now know each of these little angles here is 18 degrees. They've given me an isosceles triangle. I know if that's 18 degrees, this angle here and that angle there are exactly the same size. And so an angle in a triangle adds up to 180. Take away the 18 I've got gives me 162. And divide that by 2 gives me 81. So how many degrees is my angle arced A or angle marked A? It gives me that. I'm just going to check. 180 minus 18 is 62. 162. Divide that by 2 gives me 81 degrees. And please, when I scroll, no more questions? Goodness gracious me. Kyle has some wooden blocks. I thought that was the end of the test. Is this one the end? Oh, it is. I've got 2 more to go. Kyle has some wooden blocks, the same as the one shown. He stacks them face to make a solid cube. What is the smallest possible volume of the cube? Face to face. All right, let's do some thinking here. Anyone want to throw in an answer? I'll give it a go. Kyle has some wooden blocks, the same as one shown. He stacks them to make a solid cube. So if it's a cube, it's got to be either 3 centimeters by 3 centimeters by 3 centimeters. All right, in which case the volume of that is going to be 3. Well, it's got to be 3 by 3 by 3 because you can't do it any other way. You can't make a cube any other way. This is an interesting visualization question. And my brain is not visualizing this. Kyle has some wooden blocks the same as the one shown. He stacks them face to face to make a solid cube. So that's going to be 3 centimeters by 2 centimeters by 1 centimeter. Do another one here, 3 centimeters by 2 centimeters 1, and another one here, 3 centimeters by 2 centimeters by 1 centimeter. So putting those are going to be 3 by 2 by 3. And then can I stack another one of those? Because if I flip that on its side, it's only going to come up to 2, so that's not going to work. Oh, this is a really good question. I'm not sure what I'm going to do. I'm going to come back to that one. Let's do to question 32. This symbol is made from 2 circles and 2 lines. The circles have the same center C. Okay, the radius of the small circle is 3/4 of the radius of the large circle. The angle between the 2 lines is 60 degrees. The arc EB is 16 millimeters. The arc AB is 16 millimeters. All right, okay. What is the length of the arc PQ in millimeters? The arc of PQ in millimeters. So what we're trying to find, this one here. Okay. All right, the symbol is made from 2 circles and 2 lines. The circle have the same center C. The radius of the small circle is 3/4 the radius of the large circle. Okay, the angle between the 2 lines is 60 degrees. The arc AB is 16. All right, so if I know that's 16, this is also 16. That's 60 degrees, 6, 12, 18, 20. So that gives me that because I've got a fraction of the circle at 60 degrees, that means I got 6 lots of 16. So if I do 16 times 6, 6 times 6 is 36. That's 96. Right, so what I've managed to do there is I now know that this whole circumference here is 96. What does that say? Millimeters. All right, so the radius of the smaller circle is 3/4 of the radius of the larger circle. The angle between the 2 lines is, the arc AB is that. The radius Sheesh. The radius of the smaller circle is 3/4 of the radius of the larger circle. Yep, missing something here as well. This is an interesting one. I think I'm trying to overthink it. I'm trying to use like VCE maths here to try and do this question. The radius of the smaller circle is 3/4 of the radius of the large circle. How long has this video gone for? 35 minutes. I'm not going to do this for too much longer, guys. I may actually, for those of you who want to stop this, I may actually try and reload the values of... Here we go. I'm going to actually reload or try and come up with the answers to these two questions. Just bear with me. What's this? 2012 Year 9 test answers. So question 31 is numeracy calculator, numeracy non-calculator. So what does that say? 216? So let's go back to this one. What is the smallest possible? It's 216 cubic centimeters. And this one here comes back to be 24. So 24 millimeters. Let's see. So those are the two answers. Maybe you guys will just have to beat me to it while I sit here and... Oh, half my head went missing. Let's finish this one here. All right. Guys, to be honest with you, if in 4 minutes I don't get this, I'm going to call it and maybe add an addendum later on. The symbol is made from two circles and two lines. The circles have the same center. The radius of the smaller circle is 3/4 the radius of the larger circle. So by ratio, does that mean then that the circumference is 3/4 of 96? So let's go with that. So 96 on 3/4 of 96. That's basically 4s go into there. 24 times. 3 times 24 gives me 72 millimeters for the radius or the circumference. And again, I now want to divide that by 6 because of the 60 degrees. 72 divided by 6 is not going to give me, it's going to give me 12. So that can't be right. Or have I done that wrong? 4's into 96, so 4, 8, 14. 3 times 24, 4, 8, 12. 4, 8, 12, 6, 72. And I'm looking for 60 degrees. 360 divided by 60 gives me 6. Gives me 12, not 24 millimeters. Let me just check that answer. 2012. Year 9, no calculator. Numeracy, no calculator. Yep, definitely says 24. Yep, that one stumped me for a moment, guys. Just going to try this one here. He stacks them face to face to make a solid cube. What is the smallest possible volume of the cube? So 216. 216. What's the cube root of 216? Cube root of 216 gives me 6. So basically, it is telling me, or the answer at least is suggesting, that if I can make it 6 by 6 by 6, that's going to be the smallest possible volume of the cube. How would I know that without sitting here for an inordinate amount of time trying to guess? Or am I just looking for the highest? Nope. Or am I looking for the lowest common multiple of 3, 2, and 1, which happens to be 6? Because I can put a 3 and a 3 there. I can put a 2, a 2, and a 2 there. And then obviously I've got to put 1, so 6, 6. Well, there we go. So I don't know how I would know that without inferring it. But in this situation, I suppose, yep, I've got to try and work out what the multiple, the lowest common multiple of 3, 2, and 1 is, which is 6. And then try and work it out that way. All right, so 6, 6, and 6. That's 31 done. Okay, 32. Sheesh. The hell's going on with 32? The radius of the small circle is 3/4 the radius of the large circle. But what does that matter? He says. So I know the circumference of the big one is 2 times pi times radius. That's the circumference of the larger one. Right, the circumference of the smaller one is 2 times pi times radius 1, radius 2. And it says the radius of the small circle is 3/4 of the larger one. So R2 is equal to 3/4 of R1. All right, so Errata is 2 times pi times 3/4 of R1. So the circumference of the smaller one, nope, let's try that one again. So let's call that R large, and let's call that R small, so I get that one there. So R small is 3/4 of R large. So in which case the circumference small is equal to 2 times pi times 3/4 of R large. And 2 times pi times RL is circumference of, so the circumference of the small is 2 times pi times RL. Oh, it'd be right if I could smell. Circumference of the small is equal to 3/4 of the circumference of the large, which is what I just worked out. Okay, so have I done something wrong with this? 96. 36, 96. Let's try that one again. The arc AB is 16 millimeters. Oh, I'm an idiot. Oh, that's so annoying. Those of you who are screaming at me out there because I haven't actually just read the question. All right, that's actually 120 degrees. And 360 divided by 120 is actually 12, 24, 3. So what I actually needed to do there was do 96. Was 3/4 of 96. Which gave me, what do we say, 4s went into there twice, 24 times, so 3 times 24, which gave me 4, 8, 12. No, 3 times 24, yeah, 4, 8, 12, 6, 72. And then basically I needed to divide that by 3, not 6, you muppet, because read the question. That gives me 3's go into there twice. Maybe once 3 goes into 24. So there's my 24 millimeters. Okay, I am not sure I explained it very well, and I went slightly over my time, but obviously even me, I'm looking at going, hold on a moment. All right, so basically in this situation, if we could find the radius of this, the circumference of this whole thing here, which we could, we knew that 60 degrees of it gave me 16 millimeters. So basically, if I know that that's 1/6 of my circle, then I can basically work out that 16 times 6 gave me the 96. If I've got 3/4 of the radius of the large circle, then actually it turns out that 3/4 of this circumference will give me this whole circumference here. Again, because I want this arc length, I've got 120 degrees. That's actually 1/3 of my circle. So I basically wanted to work out what 1/3 was of 72 millimeters. All right, so 72 millimeters was what this whole thing was here, and I wanted 1/3 of it, which gave me the 24. OMG, that's nuts. All right, so those last two questions, yeah, I'm still not overly impressed with that one there, but that one there, all right, in the end, sort of got to me. Hopefully that was helpful. My name's Sam from MaffsGuru. Sign up to MaffsGuru if you can. I promise my other videos are amazing. I'm on YouTube, and hopefully I hope to see you in another video soon. Right, I'm done. Calling it a night. Take care, guys. Bye-bye.